Hi everybody. So in this video I'm going to show you how to find the volume of revolution about the y-axis. So this is where the area, this shaded region here, is rotated around the y-axis of a line x equals 0, and it's rotated 360 degrees or 2 pi radians. And when we revolve this shaded area around the y-axis, we get the solid looking like this. And I showed you in a previous video how to find the volume of this solid of revolution using the formula pi times the integral between a to b of x squared integrated with respect to y. So for this question, we're being told that our limits are 8 and 27, and these lie along the y-axis, and that y is equal to x to the power of 3. But what we need is x squared. So we need to rearrange this equation to find a squared. So if y equals x to the 3, then we can take the power of 1/3 of both sides. So now we get y to the 1/3 will equal x. And to get x squared, all we need to do is square both sides. So y to the power of 2/3 will equal x squared. And it is this term which we're going to substitute into our equation. So a volume will be equal to pi times the integral between the limits of the 8 to the 27 of x squared in terms of y is y to the 2/3 integrated with respect to y. When we integrate this, we get the volume will be equal to pi multiplied by adding 1 to this power, y to the 5/3, divided by the new power, and then we'll close that bracket, between the limits of 8 and 27. We can tidy this up by moving this division to a multiplication, so the volume will be pi multiplied by 3/5 of y to the 5/3 between our limits. So now all we need to do is substitute in our limits. So we get the volume with pi multiplied by 3/5 of 27 to the 1/3 gives us 3. So this will be 3 to the 5 minus 3/5. And then 8 to the 3rd will give us 2, and then 2 to the 5. Then we'll close that bracket. And we can work this out on our calculators. So we've got 3/5 or 0.6 of 3 to the power of 5 minus 0.6 of 2 to the 5, which is 32. And we get the volume will be 633 pi over 5. Okay?